Today we're going to talk about solving systems, or 3x3 systems of equations. Now 3x3 just simply means there's 3 equations, 3 unknowns normally. The fact that there's 3 equations is usually the reason why this is one of the harder ways to go about solving the system, or maybe not harder, but one of the longer ways to do it. Now there's 2 ways you can do this. Okay, one is you can do with substitution. Another way is elimination. So let's start with the first one, and we'll just show you, or I'll show you how to do it with substitution. Substitution, you're going to do exactly what you would think, and that is we're going to go through and set one of the equations equal to a variable and plug in to the other ones. So for instance, as I look at this, I notice here that this has an xy, yz, xz. So what I'm going to do is, if I were to set this bottom one equal to z and plug it into here, then this would have xy and so would this one. So that's what I'm going to do. I'm going to rewrite this one. Okay, so if I subtract 7x over, okay, I get negative z equals negative 7x plus 27. And if I divide by negative, I get z equals 7x minus 27. What I'm going to do is I'm going to plug this part right back up into here. Okay, so when I do that, I'll do it over here. Actually, let's do it over here. Okay, so once I take this, okay, I'm going to plug it into here. So I'm going to get negative 2y plus 3. Now instead of z, I'm going to write 7x minus 27 equals 9. Okay, so the whole point of that now I have the top one still. Top one says 5x plus 7y equals negative 1. And so what I'm trying to do is I'm trying to create a system of equations of 2 equations, 2 unknowns, because we've done that enough that we can go through and solve those pretty easily. So let's come over here and let's try and simplify this thing the best we can. So this one has a y first. I'm actually going to switch the order around. So this says 7y plus 5x equals negative 1. Down here I'm going to get negative 2y, do a little distributing, plus 21x. Looks like we're going to have minus 81 equals 9. Okay, let's simplify just a little bit more. So up on top, it's going to stay the same. On the bottom, I get negative 2y plus 21x equals, looks like 90. Okay, so let's go through and solve that. So here's an equation or a system that you've done before. The question is, what do you want to do? Do you want to try and change or try and eliminate y's or x's? Well, I'm going to pick y's. I think that might be the easiest. So I'm going to multiply this top by a 2 and the bottom by a 7. Okay, so I'm going to get 14y plus 10x equals negative 2. The bottom I get negative 14y plus, looks like we're going to have 147x equals, well, that's going to be a big number, 630. Okay, so now I can do elimination method. If I add down, the y's go away, and I get 157x equals 628. And I'm sure you know, just like I do, that if you divide by 157, x equals 4. Okay, so we got one of our numbers. Okay, it's 4. It's going to be 4 comma something comma something, because there's 3 variables, obviously. So how do I figure out the other ones? Well, we're just going to start working our way back. Okay, so for instance, here's x. Let's say I want to know what y is. I can use this equation here. So if I do that, I'll go 5 times 4 plus 7y equals negative 1. So 20 plus 7y equals negative 1. Subtract 20. Divide by 7. Okay, so there's negative 3 is my next one. And then finally, to get the z, you can use this equation if you wanted to. So I would do 7 times 4 minus z equals 27. 28 minus z equals 27. Subtract 28. Z equals 1. And there you go. A lot of work right there. But that's how you would go about solving one of these with substitution. Now, one of the, I guess, just kind of keys or hints if you're asking yourself, well, how do I know if I do substitution or elimination? Most times we do substitution when you have equations that only have two variables. Okay, when you come across a problem like this next one that I have here, you notice that every single one of these equations has three variables. So that is when life gets quite challenging. Okay, so let's give this one a shot and see what happens. Okay, so what you're going to do is you're going to take a look at all three of your equations and you're going to decide which variable you want to try and get rid of right away out of all three of them. So look at all your x's, all your y's, and all your z's. Well, I think I could probably get rid of all my x's because they're not too unsimilar to one another. And so what you're going to do is you're going to just take two equations at a time. So let's just ignore this bottom one here for a second. And if I wanted to get rid of my x's, what I'm going to do is I'm going to just simply multiply the top by negative 2. Okay? Okay, so I'm going to get, if I do that, I'm going to just write it up here on top, negative 2x minus 4y plus 6z equals negative 100. And so what I'm going to do, again, I'm just ignoring this bottom one. I'm going to combine these two together. So when I do that, my x's go away, and then I get negative 4y plus y is negative 3y. 6z plus 2z is 8z. Negative 100 plus 3 is negative 97. Okay, so I've eliminated my z's, or probably my x's. And then what I'm going to do is I'm going to go back to my original and ignore the top. And I'm going to ask myself, okay, how do I get rid of my x's? Well, I'm going to multiply the bottom here by negative 1. If I do that, I get negative 2x plus 5y minus 4z equals 79. So now I'm going to combine these. And my x's go away again. Y plus 5y is 6y. 2z minus 4z is minus 2z. And then 3 plus 79 is 82. Okay, and so what we have left is a brand new system. And so again, we just go back to what we've done many, many times, and that is solving a two equation, two unknown system. So what I would do is I'd multiply this top by 2. So I'll write it down here. You get negative 6y plus 16z equals, let's see here, how much is that? That looks like it's going to be negative 194. So let's add those together. Looks like I'm going to get 14z equals negative, let's see, 112. Okay, that seems about right. Divide by 14, z equals, let's see here, I think it ends up being 8. Okay. Yep, that sounds about right, except for it'll be a negative, because this is a negative. Alright, so all that work, and I just figured out my last variable. So it's something, something, negative 8. So let's just start working our way back. Okay, so if I want to figure out another variable, let's say y, I'm going to go back, and I can pick any of these equations I've created along the way. So I'm just going to pick, let's say, this one right here. And so I'm going to get 6y minus 2. Now z, I'll write negative 8 equals 82. 6y plus 16 equals 82. Subtract 16, so that will be 66. So y is 11. And finally, to get x, I'm going to go all the way back here, and I'm going to use this middle one here. 2x plus y, which is 11, I just found out, plus 2 times negative 8 equals 3. So 2x plus 11 plus negative 16 is negative 5 equals 3. Add 5. So x is 4. And there you go. Again, a lot of work, okay, but one of the big things simply is being organized. And so when you do elimination, you're going to look at all three of your equations, decide which variable to cancel out of all three of them, and then work on two of them, and then the other two. And then just simply work your way through it. Okay?